let's speak about the K rate, quantum communication K rate itself. So quickly, I'll go through the terms, what I mean, and afterwards I'll show the simulation. So here we have the K rate. Afterwards we have this phase. So K rate tells us what was the rate of the secure how many bits we can actually transmit error-free. This is what tells us K rate, and the idea that let's go through this equation. So we have this factor 1.5 that tells us the phase flip error rate. So for BB84, we know that half of the times we would measure in the correct basis, half times we would measure in incorrect basis. Afterwards, we have a term. Basically, all this term would mean that how many photons would be incorrectly detected. So, and this part would be how many photons would be correctly detected, and the difference between those two would actually indicate what's the achievable rate. So here I simulated actually this equation for so when would need to multiply this K rate by the frequency of the source. So if we have a single photon source, for example, that would emit a single photon at 100 megahertz frequency. We can actually see what the theoretical K rates that we can achieve, and as you can see, the K rates that we can achieve at high frequencies are on the order of kilobits. So once again, that shows that indeed this system can be used for establishment of the secure communication than to communicate data itself. But that's order of magnitude of the K rates that we can achieve, and it of course would depend on the system, on the R0 and other different factors.